Hello all, welcome to Code Hub. Today let us solve the lead codes daily challenge and the problem is shortest path in a grid and with obstacles elimination. You are given an m cross n integer matrix grid where each cell is either 0 or 1, where 0 is empty and 1 is an obstacle. You can move up, down, or left or right from and to an empty cell in one step. Return the minimum number of steps to walk from the left corner, that is 0 comma 0 to n minus 1 m minus 1 comma n minus 1. We have to reach the last cell by taking at most k obstacles. We can move in at most k obstacles. We can just remove up to k obstacles and then move in that particular cell if we have some k number of values. So basically this is we are finding the minimum number of steps, so we can go for a recursion to find all possible paths. And I can define a dp of states like m n and k, where this represents the minimum number of steps to walk from 0 comma 0 to m minus 1 comma n minus 1. I can represent like this, or else it can be like this, using at most k steps. I can define the recurrence relation and I can solve it through DP problem. But here I'm going to discuss the breadth first search approach. Rather than doing a DFS, we can go for a BFS to find the shortest path. So obviously for to find the shortest path, we can also go for another approach, which is breadth first search. So here we are going to have a queue and we are going to find the distance for each and every node. We want to have some of the information to be stored in the queue. What are the information that stored in the queue? We want to store the row and the column and the distance to reach that particular row to column using at most k steps. So this is all we needed. Even I also need the value k. So even I need the value k. So these are all the values that these are all the information that I need to store in the queue. So for that I can just create a struct quad. Since there are 4 values, I will create a struct quad where this is going to store the row, column, then k and the distance. At most I can eliminate this k cell. So first I can have a queue with the data type quad and I can define this queue. And even I need a visited array, whether I have visited this particular row and column. So I should also have visited array, but I also want to take care that that row and column can be visited for at most k times. So we just don't want to just declare a 2D visited array. We also want to declare a 3D visited array to store that values. So I will declare a 3D visited array of vector bool, where that is going to be the visited of size. I will get the size as well, grid dot size and n equal to grid of 0 dot size, whether this particular cell at I comma j and k is visited or not. That like I'm seeing, if it is not visited, I have visited it. If it is not visited, I have not visited it, so I can revisit again. So that one day I'm declaring a 3D visited array. We should take care of the k steps as well. So what I can do is I can have a boolean visited array of size m and a vector bool of size n and a vector of bool of size k plus 1, which is initialized with false. And for the first node, I can just push q dot push of 0 comma 0 comma, I have k steps and distance is 0, so I have pushed and I have to visit that particular cell as well. So 0 comma 0 comma, yeah, I think we can just use the visited array to make use of this k instead of going for it. So what we can do is we can just say visited of 0 comma 0 comma 0 to be visited, and then we can just run a for loop, sorry, while loop. So we can just we can just push all the four values, which is 0 0 0 0, and we are into the queue, and the visited of 0 comma 0 comma 0 is to be 1. And first I will run a while loop while not of queue is empty. If my queue is not empty, then what I can do is first I can get the node auto node equal to q dot friend and just pop that out. Now what I can do is int row equal to node dot row, int call equal to node dot call, int k equals to node dot k, and int distance, and now my current distance is equal to node dot distance. If my row and call, if my row is equal to m minus 1 and if my column is equal to n minus 1, I have reached that particular last cell of my rows and columns in that grid, so I can return my distance till now. So that is going to be the minimum distance. Else I want to surf through all the four directions. So four directions I can just declare a direction array, static int direction of 4 cross 2, 4 cross 2. So my left can be minus, so my up can be minus 1 comma 0, then my down can be 1 comma 0, then my right can be 0 comma minus 1, and my left and right can be now 0 comma 1. So my directions are this, and I can just run a for loop int I equal to 0, I less than 4, I plus plus, int new column new row equal to current row plus direction of I 0, and int new column is nothing but call plus direction of I 1. So I have my new row and new column. If my new row I is greater than or equal to 0 and my new row is less than m, and my new column is greater than or equal to 0 and my new column is less than n, and if it is not visited, visited of new row, new column, and my new row, new column, and my k. So if this is all in boundary, then what I can do is I can go inside the loop, inside the if condition. I can generate the new k. New k is nothing but my current k value plus my grid of my new row and new column. So the new key is nothing but my k plus grid of new row and new column. Why is it so? This will give either 1 or 0. So I can just have at most k obstacles can be eliminated. So if my new k is lesser than or equal to the given k value, which is the past k, and if it is not visited, visited of new row, new column, and my new k, if it is not visited, I will just visit it, new row, new column, new k equal to true, and I have visited now, and I should just push all these values into my queue. Q dot push of new row comma new column comma new k comma distance plus 1. So now I have pushed it into my queue just. And finally, if at the end of the day, if I couldn't find any of the path, then I will just return -1. So hope you understand what I am doing this, and even it is readable now. So let us try to figure it out what is. So it is int I. Okay, great, it gets accepted. And what will be the time complexity of the solution? The time complexity will be m cross n cross 4, since there will be m cross n cross this 4 directions is happening. So the time complexity will be that, and the space complexity will be m cross n cross k. Let us try to submit the code. It should get accepted. Superb, it got accepted. Hope you like the solution, and let me know in the comments if there are any suggestions. And I will try to give a walkthrough of the code first. I have created a quad values, and then so now we have the visited 3D array, and then the directions, and we have pushed all the 4 values into the queue, and we have visited the n 0 comma 0 comma 0, which is all the 3 dimensions, and we are running a breadth first search using queue while queue is not empty, and then we are just taking those values, and if I have reached the last row and last column, then I will return the distance, else I will surf through all the 4 directions and just see whether it is not visited, and if the current k is greater, current new k is greater less than or equal to the given k, then I can just visit it and then push it into my queue with the incremental distance +1. So hope this is you got it. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.